so 9.11 is learning to graph several different shapes. Circles, ellipses, hyperbolas, or parabolas, hyperbolas, and so on. Now, if you take calculus in college, you need to know the formulas, because you do something in calculus where you need to know, basically you're going to spin these shapes around an axis. So just for now, trust me that you need to know this stuff. It helps you, in calculus you'll need to know these because it will help you find different, you could find the solids of odd shapes by using this. So there is a use for this. Alright, here's the basic thing. Most of these will have two square terms. The x term will be squared and the y squared will be termed. For example, Andrew, you might know this. If I say x squared, let me start again. X squared plus y squared equals 100. What shape will I get?
A parabola?
No.
No?
Anyone know?
Right.
Turns out it's a circle. Now, remember our standard way of doing this. We always find these as a function of x. And the reason we do that is when we graph, we make the x-axis the horizontal and the y the vertical. So here's the step in all of this section, is we're going to rewrite these equations so that y is the dependent variable and x is the independent variable. And you remember what that means? I'm going to end up with y equals something. So what do we need to do to solve this for y?
Subtract x squared from both sides.
So I get y squared equals 100 minus x squared. Andrew's right. Everyone see that? All right. Now I don't want y squared, so I'm going to take the square root of both sides. So that's going to give me y equals what? Plus or minus the square root of 100 minus x squared. Now, remember when we talked about domain and range? Don't remember what chapter it was in. Domain is all the possible numbers I can put in, and it will, for a particular function, and have a real solution. And range is all the possible answers. Remember that? Domain and range?
Yeah.
So I cannot put any number in for x and get a real number answer. If I put x is 11, what's 11 squared?
121.
121. What's 100 minus 121?
Minus 21.
Minus 21.
That'd be imaginary.
That'd be an imaginary number. So there's a limit to the domain, that is the numbers I can put in for the independent variable. In this case, what's the maximum number I can put in for x?
10.
10, right?
And the minimum is negative 10?
No, you could do unlimited negative because it would become...
No, I couldn't. If I did negative 11, negative 11 squared is positive 121.
So the range would be negative 11.
No, the domain would be negative 10 to positive 10. Okay? Now, if I want to graph this, let's just pick some numbers. Well, let's do, well, I already know if I pick x and y, by the way, you're going to need graph paper for this. If I pick x equals 0, right, y is what?
10.
Well, plus or minus 10, right? Hang on one second. Right? Because plus or minus here, if I plug in x is 0, I get the square root of 100. The square root of 100 is plus or minus 10. Right? What if I plug in x is 2? Well, I get what? Plus or minus the square root of 100 minus 4 is 96. So I get plus or minus the square root of 96. Well, there's bound to be something. I think 16 goes into that. Someone check me. Use your calculator. I think 16 goes evenly into 96.
Oops.
Right? 6.
Yeah, 6 and
So it'd be plus or minus square root of 16 times square root of 6, which is plus or minus 4 times the square root of 6. Right? And then how about if I do x is 4? Let's try x. Well, let's try x is 4. What do I get?
84.
84. So it'd be plus or minus the square root of 84. 4 goes into that. So it would be plus or minus the square root of 4 times the square root of 21, or plus or minus 2 times the square root of 21. What if I try x equals 6? What will I get?
Let's see. 64, so it would be 8.
It'd be plus or minus 8. But look at that, 6 and 8, those are whole numbers. And so on. If I did x equals 8, what will I get? 8 squared is
36. So it'd be plus or minus 6.
plus or minus 6. You see that? And if I do x equals 10, I would get what?
0.
0. Alright, so now I could graph these. This will not be easy to do. We'll do these for homework. So 2, 4, 6, 8, 10, 2, 4, 6, 8, 10,
What shape are these in?
2, 4, 6,
Square root.
4, 6, 8, 10. Well, I know if x equals 0, where is that on my thing? This is x and this is y, and I did these by 2.
So it would be either side on 10
So
and negative.
if x is 0, I would get this point and this point, right?
Yep.
And then if y is 0, or if I get x equals 10, I get y is 0, and it turns out if I do x equals negative 10, I get that. And then if x equals 6, 2, 4, 6, y would be 8. And if x is 8, y is 6. And so, without a lot of proof, with just partial information, this is what you get. So if you have the form something squared plus 2 variables squared equals 80, a number that is a circle. But how do I solve it, graph it? Just like I would normally. I isolate one variable. In this case, I want to solve for what?
1.
Y. Now that's a very crude drawing. You can use your compass. Well, see, you'll have to freehand this because a circle is easy to draw, but other things are not. All right? All right, look in your book for a second. On page 239. It has x squared, or excuse me, the quantity x minus 2 squared plus y minus 3 squared equals 9. And then look at what the little thing says. The graph of any equation in the form of x minus h and y minus k, let me back up. The quantity x minus h squared plus the quantity y minus k squared equals r squared is a circle whose radius is r and whose center is at point h and k. So I'll let you prove it to yourself. What that's saying is, if I had done this, May I erase this? Is